Heat pumps can struggle in colder weather, but hybrid heat pump solutions powered by propane can deliver the comfort your customers desire. Understanding how to install these systems can help grow your business and set your services apart. Get a free 2-hour online course at propane.com/hybrid.
When you think about radiant cooling, it's like the opposite of heating. God, that's so stupid to say out loud. Yeah. Yeah. And here's your award for most obvious saying, idiot. No. So we're not sure exactly.
That's what I was saying. I have no clue if the radiant floor cooling actually works.
Oh, I'm sure it does.
It does.
Okay. All right, let's get into it.
Yeah. Okay.
No, sorry. Go ahead.
I was going to say it's not currently running, if that makes any difference. So
okay. Well, that means equilibrium. Then it met the load, right?
We are satisfied.
I wonder if anybody even knows what we're talking about yet.
Probably not even a clue. Well, maybe if they follow on the IG.
Yeah. Yeah. And if they listen to the last episode, they know they're listening to the Make Trades Great Again podcast. I'm Eric. He's Andy. And Andy, it's only been about 12 hours since we were together last. But,
that's right.
Something like that. 24 hours. I don't know. But the last few days we just spent together in Missoula, at your house, at your shop.
Yep.
Like we talked about in the last episode. And it was a fun time to be had by y'all, but in the end, the goal was achieved. We successfully replaced your electric heating boiler with, drumroll please,
the new Viessmann AW100. Yeah.
The VitoCal air-to-water heat pump.
Yep. So we ended up putting in the 1.5 ton model, the little bitty guy, which I think is going to work just perfect. I'm pretty excited. So, like Eric said, we got rid of the electric boiler. We put up on the mezzanine of above where I'm currently sitting right now. We put the wall-mounted indoor unit on the wall up there. Put the buffer tank next to that. Piped it into the outdoor unit outside. So we got a monoblock unit outside.
Yep.
The outside component of it. So we've got some 1-inch PEX that runs from there. Runs up the wall through some nice brown line hide that was a struggle.
It was a struggle. It was
not a defect, but a sizing defect on my part because I was like, oh, we can get that in 4-inch. So
we did, and so that means that you are correct.
It can be done. Not easily, but it can be done.
Yeah.
I haven't been out this morning to see if it. And after it cooled off overnight, if it blew the cover off or not, but I think it's fine.
That's a good point, actually. It could actually happen.
Yeah.
I hope
it's pretty snug.
If any bird or something impacts that line hide, the thing's going to explode. It's really jammed in there. No.
Yeah.
It's such a cool system. Individual components about, all together, like, a couple things individually about the Viessmann system are really cool. We'll get into that in a minute, but I've already got a bunch of messages and people are asking questions about radiant cooling because I posted that little reel yesterday, tagged you in it.
Yeah.
And showing, like I was just being goofy in the video, but it was just like, hey, dude, this floor is actually cooling off. That's kind of where I left it because we did the install.
Well, so when you were here yesterday, the slab right inside the door where like the sun had been shining on it.
Yeah.
The day before, so when we came into the shop yesterday morning, it was warm. It was toasty warm in the shop. I got up early, popped the overhead door open, used some latent cooling of the outside air and vented out the shop and it cooled down. It was fine. However, after 4 hours later, after we had got the unit up and running, I grabbed my thermal camera and it was still like 76 degrees or something like that was the slab temp. So it was still
warm.
Close.
It was still 80 degrees in some places too, because I was using your camera to look around the shop when we very first turned it on.
Yep.
And a lot of the slab was 80 degrees.
Right. And so air temperature was actually lower than the slab temp. So theoretically it was heating.
Right.
When we got it all up and running, we went and had lunch. You guys jumped on a plane, took off. I think I texted you at like, what was it, 8:00, 7:30, something like that.
Yeah.
6, 7 hours later, let's just say that.
Yeah.
And the unit, to my knowledge, had ran more or less continuously at that point,
Yeah.
at
Probably.
steady state, right? We were maintaining, I think I was targeting 55-degree entering water, and that's what we
Okay.
had. So when I came out here, the exposed piping was completely dry, no condensation for everybody that was worried about
Yeah.
condensation. We had 55-degree entering water. We were coming out of the slab at that point at 68. So the temperature split had narrowed up a little bit, which I thought was a little bit interesting, but nonetheless, it was working. And the slab surface, we had the coolest space that I saw was 64. So we had dropped almost 20 degrees slab temp.
Well, it's interesting when you think
through the
about
heat of the
cooling.
day.
When you think about radiant cooling, it's like the opposite of heating. God, that's
Well,
so stupid
surprise.
to say out loud. Yeah. Yeah. And here's your award for most obvious saying, idiot. No, like on the Delta T, I'm thinking Delta T. Okay, so
Yeah,
like
right.
we're targeting a pretty wide Delta T with certain types of radiant systems.
Mhm.
Like in a garage floor, 20 degrees, 25 degrees,
Perfect.
honestly isn't that bad at all if you want to.
No.
If you've got a condensing system, especially because then you've got that boiler's likely to be
Right.
running like at the very low end of condensing, like the lowest end, like basically just pouring water, right? And we're recapturing that energy and efficiency goes way up. With the radiant cooling though, that Delta T is going to be wide at the beginning, but it's going to shrink as we get nearer the target surface temperature of the slab. So
Right.
it's interesting it doesn't surprise me at all that only after 6-8 hours that Delta T was basically cut in half.
Yeah.
Or maybe not quite, but close, right?
Right. Yeah, I came out here at, I don't know, we got up and worked out this morning and 9:00 or so. Came out to the shop just because I was like, oh, I need to go out and see it. I'm just curious if that thing's still running. And looked, and it was off, and circulation pump is off, so it means that it met its target set point, shut off the outdoor unit, and then further exceeded the indoor by the differential and shut off the indoor pump as well. So it was just off. So these systems run, if anybody's familiar with Viessmann's older circuit technology, where you basically are set up to run constant circulation until you break your set point by several degrees.
Right.
And that's kind of the way this is set up. And I haven't dug into it far enough to see what that is. I think it's 3 degrees or 2.6, something like that.
Okay.
So if it drops 2.6 degrees below the set point, it'll shut off this constant circ because there's no point in doing for circulation.
Right. Right.
And so I need to, we talked about it on, in the Instagram stuff and, it'll be come out in the video. I'm currently looking and, I'm going to make an attempt at, pulling the Modbus data off of that communication link between the indoor and the outdoor. And I think I can pull every one of those data points in, and I'm going to see if I can't geek out a little bit and put that on a spreadsheet so I can see, what the frequency of the outdoor unit was.
Yeah.
Based on because their outdoor unit has current transducers in it, so I can monitor amp draw and all of that stuff. And which is really kind of interesting to me because last night when I came out at 8:00, it was sitting there running at that steady state, 55-degree entering water, 65 coming out. And we were doing that with 2.1 amps of power.
2? Because it had been running at 5 amps only,
right?
When we had initially turned it on, and it was making like you had turned it real low on the outlet temperature just to see what it would actually produce, and it was running like pretty steady at like 45, 46 degrees Fahrenheit.
Yep,
and it was at that point only drawing like 5 amps or something like that.
Right. So I mean, indoor pump. I looked. I ended up putting a Grundfos Alpha on the system side, so it's pumping down through my manifold. I got it connected and looked at the data on it. It was using 5 watts of power to move 2.5 gallons a minute at 4 feet ahead. So
Yeah.
this goes back to our design, right?
Yep.
And we talked about this. I could have easily done this with 4 300-foot circuits
Yeah,
and
but
done it
you
with
have
2 gallons a minute
yeah,
at 15 feet ahead. But I
right.
added a 5th circuit, cut that down, each one of them by a fourth or quarter, basically.
Yep.
And dropped them down. I think my longest circuit is 240 feet. And so
Yep.
when you're moving a half a gallon a minute through 240 feet of PEX, it's got like little to none for resistance. And so therefore I can pump with 5 watts of power instead of having a high head circulator just running its guts out to try and jam a half a gallon a minute through it.
Yeah. Yeah.
So that's
There's
some of that long-term,
payback.
payback.
Just
did
based
that.
off the design alone,
Yeah. Yeah. I did the, and it goes back to it's same thing like we were talking. Did I need to run 1-inch pipe from my manifold to the buffer tank for 2.5 gallons a minute? No, I didn't. But it's like 15 feet of pipe. And if I'd done it in 3/4, I may have been 2.5 gallons a minute at 10 feet ahead.
It would have increased the head. I mean, there's a couple fittings in it.
Yeah.
There's, it's pretty straightforward, but it would have increased the head.
Right.
There's no benefit to it. You have glycol in the system. If you can
Yep.
get closer to, and some guys use this term pretty loosely, but if you can get closer to that laminar flow or that more gradual or lower velocity, that's going to benefit you as well for air removal with the glycol.
Yeah. And heat transfer.
So like if you've got glycol will actually hold a ton of air in it at high flow rates. And with that turbulence, it's going to keep it suspended in the fluid. It's harder for the automatic air eliminator. It's harder for that to remove it, especially in a cooling system, by the way, because we're not even going to be able to pull the air out of solution very easily at all.
No.
And so if you're doing it at a high flow rate, you're just going to keep that air in that glycol, which does, in fact, over time affect the run times, the heat transfer effective, efficiency, things like that. Glycol is not something that you can just say, oh, it's just freeze protection. It's actually, you got to think about a few different things or at least know how it's going to operate, especially if you're talking about like troubleshooting and stuff like that.
Yeah. So I was just farting around, after looking at that, and my son was out in the shop, and we were chit chatting about it, because he was working the whole time that you guys were basically here.
Yeah.
And he came out and wanted to know, kind of what we were doing and why we were doing it, and we were talking, and I was like, I wonder, what does this actually come out to? If we're 2.5 amps. Let's say we're 2.2 with the outdoor unit. We got a pump in the indoor unit and the main pump that's 5 watts. I was like, let's just round it up to 2.5 amps, right? Total.
Okay.
At 11 cents a kilowatt, what does that amount to if we ran at steady state like this for 24 hours? And I punched it into Gemini, and it came back and estimated, not certain without service fees for electric, but it would be $1.30 a day to provide 55-degree water. And I was like, well,
so what's that, about $45-$50 a month if it ran 24 hours a day at that particular load? Because that's a target too. So like the load there wasn't a ton of load. The slab was warm to start, there's no doubt, but the outdoor temperature too was relatively, I wouldn't say it was cool yesterday.
It was hotter the first day.
Yeah. It was close to what, 80 yesterday?
Yeah, something like that. Yeah, mid to high 70s.
Yeah, so it's not like it was like scorching hot by any means, but it wasn't 50 either, So it wasn't a huge load, is what I guess I'm trying to say.
What was interesting, and this was I kind of chuckled a little bit as we walked out to the outdoor unit, and I was kind of explaining to Dylan how that functions and how it works and whatnot. And I'm standing there talking to him, and I'm like in my mind thinking, this is really interesting. I'm literally standing in front of my heat pump, and I can hear the neighbor's heat pump running like 100 yards away.
No kidding.
Yeah. And I was like, that's pretty impressive. It is very quiet.
Yeah, I would say
that.
I would say that it is extremely quiet. It's got that giant fan, and then the coil in the thing is massive.
It is.
So like it's just pulling at a low, CFM
Yeah.
a lot of air, but across a massive coil. It must be how they can pull that off.
Right.
It's pretty
Well,
cool.
to my knowledge, that's the same coil in the 1.5 ton that they use in the 3 ton. And I don't know
I
that.
think physically the 3 ton and the 1.5 ton outdoor
I
units
think
are
they're the same size.
dimensionally the same, aren't they?
I think so. And then the 5 ton, you jump up to the dual fan big model, or the taller double stack, basically.
Yeah. It's a cool system because we should acknowledge too, and I should have at the very beginning, Viessmann was able to fund a little bit of our travel costs when it came to producing a video that's going to be on the Mechanical Hub YouTube. It wasn't by any means extortion or a major project. It was just like, hey, we want to go install this at Andy's place, and of course you're going to benefit from it. So can you pay for our like airfare and stuff like that? And so I want to be upfront with that. But a couple things about the Viessmann product, aside from the fact that they help, let us, help get us back together to do it, is I think it's important to note to people that aren't familiar with these kinds of systems, and the Viessmann one checks all the boxes. You got 3 different sizes. They want you to use a buffer tank with the installation, and you buy it as a package. So the buffer tank, the indoor unit, and the outdoor unit are all in like one catalog number.
Yeah.
So that's cool. And then depending on the application, we've talked about this in recent episodes, even when we talk about making domestic hot water, depending on an application, their system is absolutely capable of doing heating, cooling, and domestic hot water. So it's really and it has its own backup heat system built into it. In each of the indoor units, no matter the size of your system, there's a backup heat source built into it, electric.
Yep.
So it's an all-in-one. And I think we have an obligation to say that to our audience because I think it's useful information to know about. And also thank you to Viessmann for helping us make the video and everything. Yeah.
Yep. Well, and that's something that I'm gonna kind of keep my eye out for a short, low profile indirect. If I come up with something that's the right fit, and I mean I don't need a lot of hot water out here. It would be really cool to be able to flip that thing on and say, okay, go ahead and make hot water. I'm going to wash the van with hot water today.
It's in the wintertime, like I do it with the pump sprayer and a little, a soft hose spray down, and the van is, spick and span for the next day of work.
Yeah.
Hot water makes a big difference
Huge
in that
difference.
scenario, for sure.
Yep.
And you could get away with what do you think the smallest indirect is? 30 gallon?
Well, 30, but the problem I have right now is the 30 that I'm aware of, and there's a couple of, like Viessmann doesn't make a 30. That's the height. Lochinvar Squire does make a 30-gallon indirect, and I think that it's 46 inches. It's skinny, which is nice when you need that, but it's skinny and a little bit taller.
The outlet's on the top, though.
Yeah. And so I think it's going to be too tall. I'm going to have to look. I mean, I guess I could do. I mean, there's really no reason I couldn't. I could do one of those NTI wall hungs. That would be pretty sweet.
That'd be really cool. One thing to know, too, this is not really going to impact your install, but I think anybody listening that isn't aware, we say, I always stress, like, this can do hot water too, right? Yeah. We've had opinions on that. You and I have been very clear about how that maybe isn't the best use of a heat pump. I think people would back us up, but it is capable of doing it and it's efficient. So there you go. But it does require a different type for the best performance, a different type of indirect water heater. Yep. Viessmann offers one that is specifically engineered to meet the performance specs and given the input off of a heat pump, air to water heat pump. So
correct.
Way bigger heat exchanger inside of the tank, more surface area, because these can't produce 180 degree water. They can make domestic hot water with like 145, 150, 160, something like that with this type of tank. So performance be damned if you're going to try to hook it up to the existing tank that's been in the basement for the last 10 years or something, because it will make hot water, but it won't make as much hot water as that tank was capable of otherwise. So
okay, and that, with that, I mean, and one of the other big benefits there is I believe it's the VitoCal, or not VitoCal, the VitoCell
Yep.
100 series. The top is removable, and the buffer tank basically nests directly on top of it.
Really cool.
So that's actually pretty cool. Viessmann has got this whole tank series. I'm just going to throw it out there. I don't know how much of this is currently available U.S. markets, but there are a handful of like solar accessories and,
Yep.
along with that buffer tank that are all designed to stack vertically on top of your domestic tank. So if you have let's say you got a mechanical room with a 9-foot ceiling and you've got a 50-inch tall buffer water heater, you could put a 20-inch tall buffer tank on it twice, stacked up on top of it, and have some sort of a solar buffer tank
and heat
along
pumps and all that kind of stuff.
Yeah. So it's kind of a neat system.
Personally, no, this is just a personal Eric Ani opinion. I really like their indirects. I like their indirects, stainless steel indirects a ton because of I think the performance paired up to their boilers are great, but I like the stainless.
I like stainless
lifetime warranty.
Yeah.
So better for the kind of water types I have here too. But anyway, I hinted at it earlier, kind of individual components of the system. What I was getting at is you had mentioned the outdoor unit super quiet. That's really impressive. This thing just doesn't seem to make any noise. And even that 5-ton unit we did at my sister's place in 2024 when you came out,
right,
when that was running full blast making heat in the snowy November kind of upper, northern Minnesota weather, it didn't make any noise, did it? Like,
I didn't. I mean, it doesn't really have a mechanical noise to it. It's got you can hear the fan on high speed. You could hear the compressor at high frequency, but you're not.
But it's very quiet too. Yeah, so that was that. And then the third thing I wanted to mention on like the individual components is you and I kind of scratched our head a little bit with that 20-gallon buffer that's part of the system and how it was going to sit on top of this mezzanine. And you had considered doing it one way, the indoor unit's going to hang on the wall on the left and then the buffer on the right. And then you're looking at the tank and you said, well, the outlets are like opposing in like a 90 degrees.
Yeah.
And we were both like, what is going on with this tank? And then it turns out to be like a blessing in disguise. And I'm complimenting the engineering of the Viessmann people. We looked at that tank thinking it wasn't going to fit in the space we wanted it to. And because of how they built it, it fit in any space you wanted to because how they put the tappings on the tank, like 90 degrees to each other, perpendicular, basically.
Yeah. It is important to note too, though, and just going to throw this out there. If you're looking at the tappings, there are 6 tappings on it, right? And like you said, at 90 degrees from each other.
Yep.
Those 6 tappings, the top tappings are not the same on both sides.
Right, because they have like dip tubes or something on them.
Yeah,
right?
They redirect the water inside there slightly in order to improve performance and allow air separation. And I will say this: I mean, we purged the floor slab, for a fair bit of time, but we didn't go like crazy over the top. I don't think
it's 5 short loops. I mean, I think we did fine. It was already full of glycol. We just were pushing water through to get that flushed out of there. So
but
I think we did appropriate
on startup. Once I got the unit powered up and the pumps running, I don't think I heard but 5 or 6 little out of the air vents after pumps and everything was up and running. So I was like, oh, that's pretty dang cool.
I bet it was able to capture that, tiny little bursts in that cooling mode overnight as it was running. You know what I mean? I bet you pushed it around just fine.
Yeah.
That's another advantage too of that 1-inch pipe, by the way.
Yeah.
Is for better air removal in this scenario, especially as you add the glycol back into the system. It's that 1-inch pipe is going to be your advantage for air removal for sure.
Right.
Yeah, it's cool.
I was regretting it when we were trying to jam the insulation in the line height. I was thinking 3/4 would have been sweet.
Yeah, we probably could have pivoted, but I'm glad we didn't.
Yeah.
We did it the right way. You size the piping properly for the
Right.
design of the system. So even though you're not likely to see those load conditions,
Right.
except for in the most probably coldest days of the year, where
Right.
you're going to need a higher flow rate, and as it increases, so does the head. But
Right.
you sized it properly. These things, these systems have to have, you have to give them a shot, and so the size of
Yeah.
pipe between the outdoor unit and the indoor unit is critical because you're using it in a already supplied circulator inside the unit.
Yep.
You have to be able to move the right amount of water through it. Put it that way.
Yep.
Yeah, it's cool stuff. This stuff is, we've talked about electrification and the equipment for a few years now.
Mm-hmm.
And we've got a lot more experience with it. We'll just have to keep looking. I'm interested to see how this operates, and the litmus test for me coming from you would be, would you install this for a client?
Right.
And that's I don't think it would be a good idea to say yes or no right now.
No. I mean, in a heating application, absolutely. Right.
Yeah,
We've got one.
yeah.
I've got one. That we did. We did that one
I guess
as a paid job. On the heating side, yes. Cooling side, that's the big ticket for me.
That's, I guess, what
as we've talked. Yeah, no, and I knew where you were headed there. So, I mean, just so everybody's clear, this system's been out for what, 2 years now?
2 or 3 going on. Let's say a full 2 years. You installed one just weeks before. Together, you and I installed one here in Minnesota. So, like, this is what, your third Viessmann
air to water,
air to water, and my second. And I think it's a really cool. So I'm just so excited about the cooling aspect of it because, unfortunately, without further, engineering a system in Minnesota, we're not going to use cooling in the radiant floors.
Probably
just
not.
because the dew point.
But if I mean, let's be real about this. If it doesn't mean that heat pump wouldn't be a good application for a shop, like, right? Even in Minnesota, are you going to do radiant cooling? No. Could you do a fan coil? Absolutely.
Yeah, that's what I guess.
And you could put 45-degree chilled water into a fan coil and move air around the shop and have dehumidification and that. And I looked at that the same thing and I thought, well, how hard would it be to put a fan coil in mine? It'd be a piece of cake, right? It
wouldn't be difficult at all. And in fact, and in your case, I wonder, is this can you hook up like a dew point sensor so like it can be controlled on that in the cooling mode? So it's not producing, too cold of water. I don't know. Is operational?
I don't know.
Opportunity there for the cooling?
The cooling does not appear to have an outdoor reset schedule. Right. So you do a cooling set point. This is your just target cooling set point. And then it tries to target that from coming in from the outdoor unit, is my understanding.
I think if you could control it based off a dew point as an input, like on an outdoor reset, like you're saying, you might see a wider application, maybe get a little closer to, a more humid climate, but your climate's perfect for it. And that's why you're trying it in the first place.
Right. Well, and that's the thing, yesterday when it was, 78 degrees out or whatever, we were sitting there going, oh, look, we got condensation forming on the piping and it's 45 degrees. And I opened up my phone app and the dew point was 45 degrees.
Yeah. So there we go. Proved it right.
What was kind of cool is right as we were leaving, I bumped that set point up to 55 just because I thought, well, I'll just leave it run at 55 and see what happens. And 10 minutes later, the pipe was dry.
Yeah.
Where there previously was condensation.
Yeah. And just for clarification, anybody listening really close, the piping he's talking about was just some exposed copper near the buffer tank that hadn't been insulated yet, because you're going to insulate it. The rest of the piping, all the PEX and everything we ran was insulated, and I'll reiterate, it was a nightmare. But anyway, I'm just kidding. It was great.
Yeah.
Let's wrap it up.
Wall.
Yeah. Let's wrap it up. Dude, thanks again for having me out.
Yeah,
It's so cool
absolutely.
to do this, and it's fun to talk about for you and I hope you guys are enjoying this out there driving your across country or from one job to another. Maybe you're
Yep.
wrenching on something right now, but when you get a chance and when you're not doing that, go over to the podcast app and give us a 5 stars if you will. I
Yeah.
please. Like, gosh. I wonder if I forgot to take my medication today. All right, man. Thanks, dude.
All right. Later.